All right. So we're going to now talk about what we call algebraic properties of the 2 norm. So we'll let x and y be an element of Rn, and we'll let n be a we'll let a be a real number. Then, all right? So the 2 norm has this thing called positivity, and that is very much related to positivity in the inner product. Could you guess what we always say about the 2 norm? And here's the hint. What do we do when we take the 2 norm? We literally square each of the entries, sum up all those squares, and then take the square root. What's the smallest that would ever be? 0. So what would you say is the minimum that that would ever achieve? 0, with the 2 norm of x equal to 0 if and only if what's true? X is the 0 vector, and it would be the n by 1 0 vector. Okay. The next one is going to be called homogeneity. Homo means the same, geneity means geneity. No, I don't know. All right. If I scalar multiply inside the 2 norm, do you know what ends up happening?
Yeah, I think A is out.
We can bring it out, but what if A was negative?
Oh, it doesn't.
Would it just be A?
It's going to be A.
The absolute value of A. And we'll actually, why don't we prove that one? I was about to ask which one we should prove. Why don't we prove that one? Triangle inequality is nice, actually. So there's something called the triangle inequality in the 2 norm, and that says that if I have x plus y 2 norm, that is going to be bounded above by the 2 norm of x plus the 2 norm of y. And we may, by the end of the day, get ourselves to that level.